Welcome back to our course on computer vision. I am Kaustav Tripathi, your instructor, and today we are going to talk about edge detection in images. So, edge detection, by the word you would have got what edge detection I'm talking about. It's simple. It is our program. Whatever we are going to write a code on, it will detect the edges in that image and it will mark them out. Because if we talk about any object, if you wanna you wanna see an object, you wanna understand what an object is. The first thing you talk about its edges. By the edges, it creates a shape of something. So same way, if your computer algorithm has to understand an image, then it needs to know its edges properly. So that's the same thing we are gonna learn today. How to find out the edges in an image. Okay, so let's get on to a spider ID and see how we can do this all. Okay, so here we are. This is just a basic code here. We are like this time we are importing OpenCV logo, but we are gonna import many other images also to show you what we are talking about. Really, what this is as detection. Okay, it's a very important concept, and in computer vision field in image pre-processing field, it's a very important topic. And there are lots of methods of edge detection, like there is Sobiel method, Laplacian method, but I'm not going to talk about them. They are not that good, I would say. I'm going to talk about the one of the great method in OpenCV, that is a Kenny method, and it's a very simple method and it's a very efficient method. Without much effort, we can get a good edges from an image. Okay, so and we are gonna just this video will be totally on Kenny. So it's a simple method. We're gonna create a variable image one, and we are gonna use this Kenny method. cv2.kenny. Now Kenny method takes three arguments. First is the source image, that is our image. Now second one is the second and third argument are the thresholds. It takes one lower threshold and upper threshold between which it is gonna work. So let's give any threshold. Let's say you know let's give it 30 for an example, and give it 100 over here. We have given two thresholds between 0 to 255. We have given it two thresholds, two color thresholds. Like 30 means a lot darker, 100 means between dark and light, something. Okay, and then we are gonna cv2.im show it Kenny, h1. Okay, I'm gonna show you this so that way we can understand it a lot better. I'm gonna run it, and there you go. Now you see here, this is our original image of OpenCV logo, here colorful. But if you see here, this our edge detected image, it has detected all the edges. That right now red in the original image. If you see, there is this red color over here, and it finds out the complete edges of that red color, and it has created, very nicely has created find out all the edges and put it over here. Now this is edge detection. Now, as I told you, edges define what kind of a object that is. Now these edges are defining that it looks like an OpenCV logo, right? It's not colored, but yeah, it has a shape of an OpenCV. Even if you see the letters, these edges are defining what letter that is. So that's why edge detection is a really important concept in the image processing field. Okay, so this was a we can also play with these thresholds. Like let's say right now I'm gonna put 90 over here and I'm gonna put 200 over here, and let's run it. Let's see how they looks like. Okay, it almost same, but yeah, if you see there are little bit of a mostly the thing is it's all white image, so you couldn't all background is completely white, so you couldn't see much of a difference. But if we change the image, let's say use our Lenovo one image, let's say Lenovo1.jpg, and now if I run it, you see here it is clearly giving us the face over here. Now you can also, if you want to do a little bit of an experiment, you can use oh wait, where it's gone, let me run it again. Yeah, You can use those thresholdings, and you can convert it from binary. You can do a binary inverse so that the face can look white and all, and rest of the background becomes black. You can play with these images, but you see this is thresholding. If you see here, this even this bar over here, you see it is dark. That's why it is going to become black, and its boundaries are it are highlighted. You can see here same thing with the face. This is a this face over here. We can change the these numbers. Like let's say I'm gonna put here like again give it a old one. Let's say okay. You see here now it becomes a lot fuzzy because we have reduced the threshold to a lot lower. Okay, we have see the size between difference between the two thresholds. You see it becomes the it is finding a lots of what do you say edges in these images. Like it is finding this edge also. It is finding the edges in the hairs also. See, see this how this cool this is. You can see edges in the eyes, in the nose section, but it has got over edges. So same thing as we can do. We can work out with these two parameters, and we can find the best concept regarding this. Best edge detection with the help of these changing these thresholds. Okay, so this was in the edge detection. So I'm going to bring out one project video on whatever we have studied up till now, like edge detection, blurring, and then thresholds. Everything that we have studied here using a webcam, OpenCV live webcam, and I'm gonna create a live sketch of a person. So stay tuned. I'm going to bring out in 1 or 2 days that project will be out. Okay, there I'm going to show you how in much you will see this concept in a lot more explained way, and we are going to use some special things that I haven't talk to you about in the course, but I'll be showing you in the on that project. So stay tuned for it. If you haven't subscribed our channel, subscribe it, and don't miss out that videos. That will be a very great project over it. Okay, so let's end it over here.